Welcome to Motor Development and Skill Learning. This is Chapter 9. Let's get started. Development and aging of body systems. So again, there's individual structural constraints that take into effect. Body systems are influenced by extrinsic factors. And it's important to know the following: the average pattern of change within each system and the range of individual variations for a system. Right. So again, it's one of these things, as you go through this book, you find that again, we try to always fit everybody into boxes, right? So you're kind of like this type of person, or you're this type of person. But again, even within that, every single person has some very distinct individual differences. Some are very small, some are very large, right? And it's going to change how people do certain functions and movements and things. And so again, it's hard for practitioners sometimes with this because you look at fitness professionals. Well, I want people to squat like this. Well, not everybody can squat like that, right? Some people's bodies are not meant to move that way, and you can't force them into that, right? So you as a practitioner need to realize the individual's difference. Again, maybe there's certain things you can work on with flexibility. Maybe there's certain strength issues, but maybe not. Maybe there's structural differences. And if there are, some of those things are things that will not be changed. And so then you've got to change your thinking of, okay, if they're going to squat, what is their squat going to look like versus the majority of my other clients? Okay, so you got to think of all these different things that play into it. You have the skeletal system, muscular system, adipose tissue, endocrine system, nervous system. They all play into effect, and again, this is in fitness. A lot of times people think, all right, well, the skeleton's going to move. So the thing that's holding them back is either got to be muscles or ligaments, or again, with the muscles, the tendons, or some kind of variation of those things. So we got to work on strength and flexibility, strength and flexibility, strength and flexibility. We don't take into effect, sometimes adipose tissue, right? So adipose tissue may be in the way. Okay, well, let's have them lose weight. Okay, so you do that too. Endocrine system can play into that, right? And then your nervous system, right? So again, you've got the chemical system and the endocrine system, and then you got the if we think of the nervous, more of the electrical. Those all play into the why the body will move in a certain pattern, why the body may move at different speeds. You could have some weird synapses things going on, some weird chemical things going on that will not allow the body to do something smoothly, or they've got to figure out different ways of doing these movements, that are even different than what's going on muscular and skeletal wise. Okay. Rate limiting constraints: a system that lags in development will be a developmental rate limiter, right? It's, the weakest link in the chain is going to be the issue that makes the chain break, or it's going to be, what keeps you from moving along. In this system is, everything else can move along quickly, but this thing is slowing everything down. It's like if you decide to go run with a group of friends, and you guys all decide that, hey, there's 10 of us, and all 10 of us are going to run the same distance, and we're going to all finish together, and nobody's going to be left behind. Well, the slowest person in the group sets the pace. It is what it is. You can't go any faster because they can't go any faster, right? So examples of different systems, you have your skeletal, muscle, adipose, neurological, endocrine, or nervous system. Any one of these could be a rate limiter. So again, muscular wise, you may have somebody that's either physically weak, or they got really sick and got physically weak. So the skeletal system's fine in its development. They may not have too much adipose tissue. Neurologically, things fire, but they're just weak. Hormones and everything are fine. Muscle weakness, right? So again, you've got to strengthen the muscles. On the other hand, they could be, you've got somebody that's going through puberty, somebody that's pre-puberty through post-puberty has different endocrine, right? Different amounts of hormones and stuff. Skeletal system. Some folks are going through growth, like massive growth spurts. For other folks are like they hit their peak top growth, right? So again, these are, any one of these can be a rate limiting constraint. Prenatally, the embryo has cartilage model of the skeleton. Again, bones get harder as you get older. Ossification begins at primary centers in the mid portions of the long bones first and spreads. Prenatal growth involves hyperplasia and hypertrophy. So again, we talked about this earlier, that you both increase cell number as well as cell size, and muscles increase in diameter and length by the addition of sarcomeres, right? Again, you're getting yoked while you're in the womb, okay? So muscle structure, we have at the most basic part of it, you know, once you get through the muscle belly down to the fibrils, to the fibrils, to the myofibrils, we have actin and myosin, right? If you look down at the lower pictures down there with the actin and myosin, myosin have these little tiny head things. They're like little arms with these heads on them. When you contract, they latch onto the actin filaments. They pull the actin filaments as the muscle shortens. So you think of like a bicep curl, the bicep gets shorter. On the small, tiny micro scale that you're looking at, those heads pull the actin filaments closer together, right? And then when they release, the muscle relaxes, okay? Prenatal development, adipose systems. Adipose tissue first appears in the fetus at about 3.5 months. Adipose tissue increases rapidly the last 2 prenatal months, and adipose tissue accounts for only about 0.5 kilograms of the body weight at birth, okay? Again, even though babies are like little chubby things, yeah. But again, you got to figure, you know, 0.5 kilograms, you know, they're not very many kilograms to begin with, right? All right, endocrine system. The interaction of hormones, genes, nutrients, environmental factors begins in utero. Placenta produces its own hormones and serves as a barrier to prevent the mother's hormones from flooding the fetus's system. Nervous system, genes direct the development of structure, but extrinsic factors fine-tune the system. Immature neurons are formed, differentiate into general type, and migrate to their final location. They proliferate at rapid pace. Most are formed by the 4th prenatal month, generally have your extrinsic factors when it comes to this. This is why kids between birth to like about 2-3, I mean, their nervous system and the way the nervous system interacts with the muscular system and with the brain and the pathways and everything, and it changes so much, and you see their development happen so rapidly. Once the nervous system's in place, neurons develop axons to carry the signals to other neurons, forming synapses. Glands, organs, and muscles, there's an overproduction and some neurons and axons die off. Late in the prenatal period, neurons will start to fire electrical impulses, first at random, then forming circuits, and these branches of weak or incorrect connections will then die off. And teratogens might disturb normal migration, branching, and pruning. Again, we talked about those when we talked about developmental abnormalities in the last chapter. So again, here's the structure of a neuron. And then you see how it goes from the you got the nucleus with its dendrites, the cell body, then you've got the axon leading all the way to the axon terminals and synaptic knobs. And again, you have so many of these form that you have an overabundance of formation during that time. Childhood and adolescence. Skeletal system, growth and bone length occurs at secondary centers at the end of the bones. These centers are called epiphyseal plates, or growth plates as we typically call them, or pressure epiphyses. Increase in bone girth is called appositional growth, and where muscle tendons attach to the bone or growth areas are called traction epiphyses. Cessation of bone growth, growth at the epiphyseal plates or the growth plate stops at different times for different bones. And all are typically closed by about 18 or 19. Closure occurs at younger age in girls. And what does this reflect about connection between skeletal growth and maturation? Girls mature much faster than boys and typically do not grow near as tall as boys in general, right? Not always, but in general. Assessment of skeletal age. Hand and wrist x-rays compared with standards for average skeletal development by chronological age. X-rays matched with pictures for ossification at ends of long bone and in short round bones. If the x-ray taken at a given chronological age matches the standard for an older age, then the person is an early mature, right? So again, this how they, you know, a lot of times they'll use x-rays to try to predict how much more growth you have or don't have. So hand and wrist x-ray to assess skeletal. Again, you can see on the right, everything is, you see a lot more white developed bone. You see on the left, especially if you look at the wrist, you know, like look at the 8 bones in the wrist. There's, you can see 1, 2, 3, 4 of them have calcified or ossified, and you can't see the rest. It doesn't mean they're missing. Well, actually, I take it back. There's 5 of them that you can see that are calcified. And again, not all of the bone is even calcified, right? And so when you see that, and then you can look at the rest of the bones in there as well, not as much ossification, calcification has gone on. Therefore, the hand on the right is more fully developed than the hand on the left. Childhood and adolescence muscular system. Postnatal growth mainly involves hypertrophy. Muscle growth follows a sigmoid pattern, and differences between sexes become markedly marked in adolescence, especially in upper body musculature. All right. Again, boys will tend to have more of it than females. Muscle fiber type. Adult muscle is composed of type 1, type 2A, type 2X, and type 2B fibers. Now again, the type 2B is one of those ones that we have kind of moved away from in literature. There's the A, the AB. Again, there's the type 2B used to be what we, or type 2X is what we used to call type 2B. But again, it's more of a transient fiber as we look at it now. So if you're wondering why there's an X and a B, that's why. There's also A, B, and some other ones that are in there. But at birth, 15% to 20% of fibers are undifferentiated. By age 1, distribution of muscle fiber type is similar to adult distribution, and exact proportions will vary amongst individuals. What does this say? Some folks will have more type 1s versus type 2s. Again, what does that mean when you develop, you know, and again with the type 2s, you know, if somebody that's got a lot of type 2X naturally can basically bulk up quite a bit more than others. Somebody's more type 1 will be naturally more cardiovascular. You know, when they train, if they train cardiovascularly, they're gonna see greater cardio gains than somebody that's type 2X and so on and so forth. Somebody that's more type 2A is going to be more well-rounded. Like if they have a lot of type 2A fibers just naturally, you know, not migrating based on their training status, they're going to be, you know, more I guess able to cross train. You know, they can, you know, they're more athletic across the board, so to speak, just based on muscle type, not based on actual performance abilities. But cardiac muscles, prenatally the heart grows by hyperplasia and hypertrophy. Postnatally, the heart follows the sigmoid growth pattern. Heart and blood vessel size are appropriate for body size in childhood and adolescence. In old age, the heart can lose elasticity and valves can become more fibrotic. And again, you know, partially genetic, partially on what you do or don't do that's good or bad for your body. Adipose system, some fat is needed for energy storage. Again, you know, everybody's like, I don't want to have fat. Well, you got to have some. All right. So again, you need it for energy storage. We need it for insulation and protection. Fat increases rapidly until age 6 months, then gradually until age 8. In adolescence, girls increase fat more dramatically than boys do. Sorry, ladies, I know y'all don't like to hear that, but you do. But nice thing is y'all carry it a lot better than we do. You guys can look a lot more fit with a greater percentage of fat on your body than a guy can. Growth is by hyperplasia and hypertrophy, the latter more dramatic in adolescence, and individual variability is also great. So, body fat distribution changes with growth. Children have more internal than sub-Q fat. Um, you know, um, again, when we don't worry too much about that in the kids, as adults, folks that tend to have more visceral versus subcutaneous, they can actually be attributed to having greater risk for things such as heart attack and other organ issues. But again, in children, it's not a big risk factor, so to speak. Sub-Q fat increases from age 6 to 7 years until age 12 or 13 in boys and girls, and sub-Q fat then continues to increase in females. Endocrine system, this system plays a role in regulating growth and maturation through chemical substances called hormones. Excess or deficiency can alter your growth. Major hormones involved in growth include the following: growth hormone, thyroid hormone, and 2 gonadal hormones. Endocrine system continued. These hormones stimulate protein anabolism, so tissue building. Neurological feedback loops regulate your hormone levels. So if they're high, it tells the body they're high. If they're low, it tells the body they're low. Each hormone may have a critical role in development at specific phases in the lifespan, and insulin plays an indirect role and is vital for carb metabolism as well. Endocrine glands, you got your hypothalamus, pituitary gland, anterior and posterior, your thyroid, parathyroid, heart, liver, adrenal glands, the medulla and cortex, your pancreas and kidneys, ovaries in women, and testes in males. Growth hormone is secreted by your anterior pituitary gland. It's necessary for normal growth. Deficiency can result in growth abnormalities. And again, in some kids now, they will actually put them on growth hormone if they have a lack of growth hormone. Thyroid hormones, they're secreted by the thyroid gland that influence whole body growth, and one plays a role in your skeletal growth as well. Gonadal hormones influence our growth, sexual maturation, sex organs, and secondary sex characteristics. So androgens are secreted by testes in boys, adrenal glands for boys and girls. Hastin epiphyseal growth plate closure promotes growth of muscle mass. Estrogen is secreted by ovaries in girls and adrenal cortex in girls and boys. Hastings, the epiphyseal growth plate closure, or hastens. I don't know why I keep saying hastens epiphyseal growth plate closure, and promotes accumulation of fat. Childhood and adolescence the nervous system, brain growth increases rapidly after birth. Growth involves these factors: increases in size of neurons, prolific branching to form synapses, increases the glial cells for support and nourishment of the neurons, increases in myelin to insulate the axons, and stimulation of learning increases the number of synaptic connections. Susceptibility to extrinsic factors, poor nutrition can stunt brain growth. Injury to the left side of the cerebral cortex can result in language deficits, but increased stimulation can expand the number of synaptic connections. Spinal cord and lower brain centers are relatively advanced at birth. Cerebral cortex gradually becomes more functional after birth. Myelination of the axons allows faster conduction of neural impulses. Again, can make you quicker in actions and reactions. And direction of myelination tends to follow direction of the conduction. Skeletal system, bones or skeletal system, as my Canadian professors used to call it. Again, that's why I hear when I see the word hastens, I always want to say Hassan's head. Too many too many professors during my health or during my science courses that said things like skeletal Hassens. Um, instead of arteries, they said, instead of capillaries, they said capillaries, things like that. Anyways, I still have to train my brain out of that sometimes. All right. Bone undergoes remodeling through the lifespan. Old bone is absorbed, new bone is formed. In adulthood, bone growth slows, fails to keep pace with reabsorption, and bone becomes more brittle in older adults, a lot of times leading to osteoporosis. Again, structure itself changes little unless it has osteoporosis. Osteoporosis leads to rib cage collapse, stoop posture, reduced height, and extent of bone loss is influenced by hormone levels, diet, and exercise. Muscular system, loss of muscle mass is minimal until age 50. By 80, on average, 30% of muscle mass is lost. Loss occurs in number and size of muscle fibers, the latter usually after age 70, and whether type 2 fibers undergo greater loss is unclear. Adipose tissue, both men and women tend to gain fat during adulthood, but this is not inevitable. This is heavily influenced on diet and exercise. And again, when we talk about exercise, it's not just about going to the gym, but your overall activity that you do throughout the day. An increase in trunk fat or increases in trunk fat are notable, but sub-Q fat on limbs tends to decrease. Again, you can give examples of excess adipose tissue serving as a rate limiting system. Again, think of your flexibility and movement patterns that are altered because of it, right? Endocrine system imbalances may develop among nervous, endocrine, and immune systems. Thyroid disorders are more prevalent. Thyroid disorders used to not be very prevalent. There's a lot of theory on why they're increasing. Part of it may be that it just wasn't diagnosed a lot several years back. The other thing is with the increase in people that are constantly changing their diets, excess here, then, feast and famine, feast and famine, feast and famine. And the role that the thyroid glands play in both, you're eating too much or you're not eating enough, and asking it to, like almost overloading the system has been another theory, as well as a few others on why those disorders seem to be on the increase. Decreasing gonadal hormone levels are associated with loss of bone and muscle tissue. Nervous system continued. Traditional views is that aging brings about loss of neurons, dendrites, synapses, neurotransmitters, and myelin. New imaging techniques document neurogenesis, which is division and propagation that breaks the neural network links, cause detours, and therefore slowing. Yet exercise promotes improved cognitive function. All right, so keep exercising. So older adults who remain mentally sharp, what do you think is a result of that person's maintenance of cognitive function? And again, a lot of research will show folks that, mentally stimulate their brain a lot. So they try to keep sharp mentally, and also physically tend to be able to keep those things better than others. Model of constraints of the body systems just discussed, which one interacts with others and how and for what functions. You guys can think about all that. I'll give you the short. They all interact, right? They all interact with each other. So again, systems interact as they develop in age. During periods of rapid change, a system might be more sensitive to extrinsic factors. The extrinsic factors play a greater role, and genetic factors a lesser role as one moves through life. And the model constraint shows that a system can act as a rate limiter during growth or as an accelerator of aging. All right, let's see if it'll let me end this thing. Come on. And now I can see something. And a little thing spinning. What is the most frustrating thing to see? All right. So that's it. If you guys have any questions, let me know. And next will be chapter 10.